it's become clear to most of us who've dealt with storage for a long time that there are at least two types of data, that which deserves a lot of performance and that which doesn't. And there have been several attempts over the years at figuring out which data goes in what location. And basically these have broken down lately into terms we call caching and tiering. And so today we're going to try and settle the great debate, doth thou cache or doth thou tier? Or do we simply spend all of our money and buy the expensive stuff and just use Dom Perignon on our cornflakes because we can? And so our esteemed panel here includes gentlemen from several of the vendors of hybrid arrays who have their own solutions for determining how we meet the miraculous goal that we used to call information lifecycle management, that is putting data in the place where its value and the cost of the storage are somewhat in line. We've given up on that term for several very good reasons we need not go into today. And so I'm going to ask my esteemed panelists to introduce themselves and let us know just from whence they come. Lee?
Hi, Lee Johns. I'm from Starboard Storage. We haven't had a chance to speak to you guys, but we provide a hybrid array. And we're one of those guys Robin talked about. We're doing disk management in a completely new way to really enable us to manage large capacity disks going forwards, as well as take advantage of solid state.
George?
Great. I'm George Symons, Chief Strategy Officer for Nexsan. And we have taken the approach of caching versus tiering for our hybrid, unified, dense storage system.
David.
My name's David Floyer. I'm CTO and co-founder of Wikibon. And we are not a manufacturer of disk drives or solid-state arrays, but we do a lot of commenting on the great work that all you guys do.
And Rajesh.
I'm Rajesh Nair. I'm from Tegile Systems. We don't sell Corollas, but we do sell hybrid Corollas, hybrid Teslas, and hybrid Ferraris.
See, and I was always wondering why we didn't have the minivan, but sometimes you just need the golf clubs. So certainly, in our last panel, we had several representatives of the all-solid-state vendor community who essentially asserted that the data placement, that figuring out which of your data required performance and which of your data didn't require performance was something best left to those individuals who had some supernatural knowledge to know how to do that. That I could, by my application, say, this is very important data and this isn't. Do you guys buy into that? Can we assume that the storage administrator is that bright and has that much time? Or is this a responsibility that we should be passing off onto equipment to say, well, I can collect more data than you can because it's all I do. Where do I put the data?
I think actually it's really a function of what those customers are doing. A lot of the people that we deal with have large amounts of data, but they have budgets in the $50,000 to $100,000 range to try and manage 100 or 150 terabytes of data, and in those environments they don't necessarily know a lot about their applications. They're not experts in all of the issues around I/O, and simplicity is really what you're trying to deliver. You're trying to make sure that the data gets to the right place for them, based on really solid storage algorithms and the caching algorithms that we use, rather than have them have to go in and try and understand how to manage their data.
So after living the bleeding edge of ILM for way too many years, I can assure you that none of them have any idea what data goes where. And this is small companies, this is Fortune 50 companies. I spent way too much time trying to talk about where data should go. And it all came back to, you just got to put it at the right place, because we have no idea. So no, I don't think the admins are going to spend the time, have the time, or have the knowledge of what data goes where. So it does need to be an automated process. Systems need to figure out the optimal placement or how to give the best performance for the data.
So clearly there are disk drives, which are very, very high capacity and low cost per gigabyte. And there are flash arrays with a flash technology, which is great for I/O and great for bandwidth, but costs more. And the two have to live side by side. There's no way that everything can be in flash, and clearly there's no way these days that everything can be in disk. I'd like to suggest there's another dimension of this, which is the applications themselves. The applications at the moment are constrained by disk-based storage, and releasing those constraints will release the applications to actually be more efficient and be able to do more I/Os per transactional and more I/Os per query. And that will be a high driver towards the adoption of flash being containing all active data. So the question is, what do you do about the back end? And then you ideally would like an environment where you move data to the back end once, if you could, to die basically, retain some metadata just in case you needed it. So a combination of applications and storage mechanisms to try and achieve that nirvana, I think, is going to be the way the technology is attempting to drive.
I feel there's actually two ways you can peel this onion, because there's, to some extent, an application knows best what it wants to do with its data. And there are certain applications that can do this very well. There's very good reason why in a VDI environment, let's say using Citrix, you would put a PCIe SSD on the host side, because it can absolutely cache some data, and you can have very fast access to that data. But in a multi-tenancy environment where you have multiple applications using a storage array, there's just no way a human being is going to be able to figure out beforehand which data is going to live where, and over time, especially over a period of 5 to 7 years, manage that data appropriately and keep moving that data appropriately to get the best optimal use of the system. So the obvious answer is you have to do this on the storage system. You have to figure out efficient caching mechanisms. You have to figure out efficient metadata mechanisms in order to make sure that you absolutely know where all that data lies and can give people really efficient access to this. So if you have an all-flash system and you got really reliable, cheap flash, then we can all go home. But we don't. I mean, reliable flash is expensive, and when you want to use that small amounts of reliable flash in the system, you absolutely want to use it for the best purposes. So use it for caching, use it for write caching, use it for read caching, use it for metadata. These are the three areas where you can very effectively use flash to give the whole system a feel of a solid state flash access pattern, whereas and latencies, whereas you get the capacity of SAS drives, nearline SAS drives, with the use of hybrid arrays like all of us.
So, you've all been talking about caching, and that leaves out the whole concept of tiering.
Yes, it does.
And part of me likes the idea of tiering because caching implies two copies. That there's a copy on the back end, the disk, and I'm now adding an additional copy of the data in the cache, which isn't efficient. I have two copies of this important data. Wouldn't it be more efficient to simply analyze the data, determine what the access frequency on my hot data is, promote that up into flash, and take my cold data from flash and demote it down to spinning disk? I would only need one copy, but why not?
I think there's some fundamental problems with that, because a lot of the architectures that attempt to do that are based on the old RAID controller, RAID array type architectures. And so, the problem they have is that they're then using those constructs on solid state disks, and that's not efficient. So you end up in, some of those systems where they're putting solid state in there and they're creating some kind of RAID aggregate where you have no idea how much solid state you need in that system. You haven't virtualized your solid state in any way. You really need to be able to move that data up there in a policy-based kind of fashion. In reality, we do use concepts of tiering. In our system, we write to mirrored SSDs in the system, which then lazy write down to the disk, but keep the data in the SSD. And you could, if you read immediately, back that same data, you're going to get it from that SSD. So there's a tiering concept in there, but it's all hidden from the user. I think the key thing is take away the complexity of RAID, take away the decision points, take away the impact of actually having data shift between different layers in the system, and just make it easy for people.
So, so I think your question involves time, and that's sort of a key one. If you really were looking at cold data and tiering, we're now talking archive, or we could be talking HSM, which to me is very different than this more real-time activity of tiering in a very dynamic environment. And most of the environments today I see is much more dynamic. If I really just want to archive, I know how to do that, right? And there are lots of tools that help me do that. So then when I get into tiering, I have the time problem. How often do I move that data? What granularity of data am I going to move? Am I going to move a LUN? Blocks is very hard. And how often am I going to do it? So that's part of what leads us to caching is it's real time. I can move much smaller chunks than in a tier. And sort of getting back to your point a little bit, I can do it with a lot less. I don't know how big a tier I'm going to need, but I can tell you it's going to be 5 times or more, quite often, larger than the amount of cache I'm going to need to get the performance.
Yeah, you're essentially virtualizing the
That's
solid
right.
state, and I think we'd all agree that virtualization is a good thing.
I'd like to suggest that what's different, the two merge, caching and tiering merge. Caching is traditionally very small amounts of your high speed. So if you take a disk array, you've got your traditional DRAM where the cache is, and that's been very, very small compared with the back-end disk. And the problems of caching are that it works well if the working set can fit inside that cache, and if it doesn't work very well. In fact, it's pretty bad. So the advantage of Flash is that you can make the caching, the size of that cache, much bigger. So the old days of 1% or 3%, I think, are gone. It needs to be up in the 8, 10, 20%, so that the cache is essentially a tier. It's just coming top down, if you like, and it's essentially a tier. And then if that tier has relatively small granularity of movement, then you essentially have created a tiering type system. So I think the difference between caching and tiering is going away in overall design. But it's very, very important that for caching to work is that the working set must fit inside it. And the last point I want to make is that caching it was brought up before by the solid state vendor people. Caching has in terms of IOs, has a great advantage, but it has a huge disadvantage in variance, in the variance of the IO. So for applications where variance is important, particularly some of the database applications, you've got to be very, very careful to be able to put in almost everything into that cache. Otherwise, you're going to have a really bad impact on an Exchange system or a SQL database system of some sort. So the secret to success to me is to have very, very large caches where you can put and design systems that you really can put most of that working set in that tier.
The good thing about going last is most of the hard points have been made. I can make the easy points now. So going back to the earlier question about tiering versus caching, right? I mean, this is I think David, you made some excellent points about cache can be a lot larger, but In addition to that, the points that were made were when caching doesn't work, it impacts performance quite a bit. Your data set needs to fit in that cache. And the good thing about computing power going up is that you can use that to fix some of these concerns, because you can do things like compression, you can do things like deduplication. When you do those effectively and the data set lends itself to doing that effectively, what you have is your active data set residing entirely in DRAM or...
Well, you have a cache multiplier effect. You know, if I'm getting
yeah,
5 times data reduction,
absolutely,
and my cache is 5% the size of my back-end disk, then it's effectively 25% the size of my back-end disk.
Yeah, and that has a huge effect on... Now you can define the working set as being 20% or 25% or 30% of your data. And that's enough for most mid-tier applications that you're looking at, most mid-tier customers that you're looking at. You're no longer constraining people at the 3%, 1%, 5%, or small numbers like that.
Mm-hmm.
So, yeah, well, I mean, what I'm seeing is that the people who are talking about caching are the people who are adding solid-state disk to traditional disk arrays.
Yes.
And that they're all working with constraints about granularity and frequency that make tiering like driving down the highway by looking in the rearview mirror. That, you know, one vendor, you know, once a day will promote data in 42 megabyte chunks. Yes. So if you have a 100K hot index in your SQL server, then 41 megabytes of cold data eats up your valuable flash along with it. So the next question becomes, where do I want to do this caching? You know, there are a group of vendors, and I'm following them relatively closely, who are arguing that the server is the place to implement that caching because I can have lower cache hit latency to a PCIe flash device and eliminate the latency hitting the back-end storage across whatever storage network I have. How significant is that, and who's the vendor for whom that, you know, who's the customer for whom that matters?
Well, I think, you know, it's not mutually exclusive. I mean, you can put flash wherever you want if you find that your workload, you know, requires that. Of course, you know, if you're putting it in your server, you're not sharing it necessarily amongst, you know, that many, you know, applications. You may not have the high availability that you want. I think, you know, from the standpoint of systems design here, we're not trying to deliver caching to a customer. We're trying to deliver them a storage array that gives them better dollars per gig and better dollars per IOP than the traditional arrays they can get. That reduces the cost of managing the system as well, because it takes away a lot of the complexity of some of those old, you know, RAID controller-based architectures. It's not caching because we've decided to deliver caching. It's using caching as a tool to deliver a next generation storage system. And
you mean,
you know,
when
like,
I buy my new car, I really don't want rack and peanut steering?
Yeah, I mean, you know, it's
yes, you do.
It's really a function of you know, next generation technology. Like Robin said, we have the ability to leverage, you know, x86 processors, Moore's law. I think, you know, Mark Andreessen a year or so ago wrote an article about software eats the world, and that's exactly what's happening here. I mean, you can easily run you know, your data protection methodologies. You can run your deduplication or compression or whatever other, you know, data reduction technologies you want. You can handle metadata in a much more efficient way because you've got so much more power, and that's why you're seeing these systems.
I think system is probably the right way to look at it there, because these are being designed and purpose-built with flash as a cache, for example. And I agree, it doesn't mean you can't use a PCI-based card for acceleration for specific applications where it really makes a difference. But, you know, for example, one of the things we put in is NVRAM for write cache, right? So it's not just the read cache and the write cache, which you can't do on the server because it may never make it to the back end, for example. So it really is the overall system design and how that's put together that's important. And now you're looking at a storage system versus a storage system, and that's, I think, the right way to look at it.
I think there's two very different marketplaces here, and very different drivers towards it. One of which is taking today's systems and making them more efficient for today's applications, the ones that are out there at the moment. And the way that you would design those systems is exactly as you guys are designing it, which is along the SAN model and shared storage, and you're making it, as you say, more efficient by putting large amounts of flash as a tier or cache or whatever it is you want to call it at the front. I think there's a much more important long-term driver, however. The benefit of what you're saying is making storage cheaper, and if the amount of money spent on IT is around 3%, and you can make storage, which is maybe a quarter of that, 30% cheaper, the net impact to the CEO of a company is not very much. Okay, if, however, the applications themselves can do much more because the latency of I/O, the amount of I/O that you can get into that application increases, or the latency goes down and the amount of data increases. If you can make that more productive for that end users, and there's a lot of examples out there where people do just that. They put the whole of a database into, for example, Fusion I/O or something like that. The net impact of that on the productivity of the company in a study that I did was around 20%. Now, 20% that's of the company as a whole, and that's 20% of their bottom line. And the driver for that is so much bigger. So I would suggest that applications are going to be written. They're starting to be written now in the analytics side, but they will be written on the transaction side as well, which will take advantage of flash systems in a totally different way, which is to dramatically increase the number of I/Os per transaction, the amount of data that can be handled, and pass that on as much higher function systems. In fact, applications themselves at the moment are usually a series of applications. Those can be consolidated. And the value of that is going to put, that is going to push a lot of storage further up into the servers themselves to be very, very close to the applications to reduce the latencies. And some of the technologies like atomic write, where you can really eliminate the I/O overhead and write directly to high-speed flash, are some very exciting technologies which over the next 5 years are going to dramatically change how systems are architected and how data is going to be managed.
Look, there's definitely going to be a set of applications where no arguments about it. You're going to be able to put high-speed flash on the host and improve performance, I/O performance a great deal, and of course the overall application performance also a great deal. There's absolutely no arguing with that. The question is, what kind of data is that? And what do you want to do with that storage? Is that your long-term storage? Is that going to be backed up? Is that going to be shared between other hosts? Is that what kind of protection do you need on that storage? I mean, am I going to really put in 3 or let's say 4 PCIe SSD cards, SSDs on my host, on my VMware host or my Citrix host, and use up those 4 PCIe slots for that, and get maybe what's the biggest good reliable flash drive out there? Maybe am I going to get 800 gigabytes of reliable storage there? The answer is no. I mean, you're going to use it for some set of.
I disagree.
So
they will solve those problems.
They will solve certain problems.
And the driving force of the marketplace for those high-value applications will overwhelm.
I do.
That's just like
saying the same thing. Right. I don't disagree with you that there is a class of applications where that does solve those problems. My point is that for the overwhelming majority of applications, you're going to need the capacity of storage and the data protection and the replication and the snapshotting and all that functionality, which is not going to be available on your host storage. It's not designed for that, right? So
I think a big part of this question is, first of all, when? will the next version of SAP? You know, when is the application I'm going to buy as opposed to the application I wrote? Because there we're talking about two very different customer bases. That you know, one of the problems I have with some of my fellow analysts is they look at the Web 2.0 world and they say everyone should run their business this way. But the whole idea of the Web 2.0 world is that application is your business. And your core competency is writing an application. And if your core competency is rolling steel, you buy applications. You don't write applications. And so the first question is, when can I just order from SAP this extended analytic built in as the transaction is generated kind of thing that David's talking about that requires substantially more I/O bandwidth, but gives me substantially more analytics back and therefore affects my bottom line?
Yeah, I think it's important.
And the second question is, which customer is that? You know, at what point in the market does even that become, you know, too good to be true? You know, if I'm a $50 million a year company, even if SAP's selling it, I can't afford it. So, you know, there's a lot of down the road. I'd like to stick to next year or the year after. Yeah, because clearly 10 years from now, things are going to be different. We can, you know, David and I can argue about 2 years from now, 5 years from now, 7 years from now. Next year, not 10 years, probably in between is gray.
Yeah, I think it's important to characterize the customer because, you know, the University of Arizona, you know, is a good example where they've got a large binocular telescope. They're looking 2 billion light years back. They're getting all this data coming in from that telescope. You know, their data is growing at 30 terabytes a year. But at the same time, they've got to run Exchange, they've got to run their VMware workloads, they've got to run a billing system. Those are the types of customers who are having to try and get performance for the workloads that require it and the cost down, you know, for that data that they're keeping. That's important to them, and they're not going to go put anywhere else. You know, those are the types of customers that really require these kind of architectures.
Right, and so my only twist to that is it's not the size of the company it's the application. It really is. And within a Fortune 50 company, I'm going to need to buy an all-flash system for a specific set of application, quite probably. But I've got a tremendous amount of my infrastructure that needs 30 or 50,000 IOPS, low latency, and you know, I don't want to pay $24 a gig for that.
Well, so then, you know, a perfectly valid question would be, where does that intelligence go? You know, would the best solution be to have the host say, there's a disk and there's a flash disk.
Right.
Let me figure out where that data goes.
So
even if we're
here's where I'm with David. The host, no. An application, yes. I would like to get to the point the application knows this.
Okay.
And
so
we're just not there.
We're not there.
No, we're not.
Yeah.
Okay. So you guys are arguing, and you know, I think I might be able to buy this, that we need to make this decision either at the top of the stack or close to the bottom of the stack.
Yes.
Yes.
But that all of those places in between, we either don't have enough information or we don't have enough intelligence.
Correct.
And it's better to be at the top or the bottom.
Yes.
Yes.
I think I'd just like to correct one characterization. It's only for the $50 billion companies or whatever it is that this is applicable for. The particular example that I looked at was Revere, which was a 200 person company that was able to improve their productivity by 20% by putting everything in Flash. They did it because all of the functionality in the software that they couldn't use when it was on disk suddenly became available to them to use and use the system much more effectively.
Okay. And my only question would be, how much performance did they actually need to do that, and what latency issues were there before and after? Because maybe it didn't all have to be.
But I think that's a bit more detailed than
we're not going to have that discussion
get into
right now.
today.
Don't worry.
Because Andy has a question.
So my question is, are you arguing a problem that's already been solved at the processor level of cache consistency, of how to maintain same thing now with flash storage. It seems to me that we can apply the same cache consistency rules to flash storage that we do to processor cache, where if you don't need to share it, you pull it in close, and we already have the concept of affinity for applications running on certain hosts.
Right.
If you're not going to have the concept of affinity, you have the concept of that you pull it into a closer cache if you're running it, and if you need to share it, it needs to get pushed to a farther away cache. I mean, it's a problem that's been solved at the processor level. It seems that you can solve it at the storage level as well.
Well, I think the what you're talking about is the overall elements of how you handle caching. I think the benefits, and we talked about this a little bit earlier, is this is a storage system that changes things pretty dramatically for people. So, we heard the flash guys talk about 15K drives and eliminating those. Now, you don't really have to use 15K drives. You can use large capacity 7200 RPM drives for lots of data. That reduces your footprint. It reduces power and cooling as well. But it gives you very low cost at the back end. So, when we're thinking about what we're delivering, we're not delivering caching, and we're not, necessarily, I think the guys here are thinking about, your overall architecture within an enterprise. We're looking at how do we help customers consolidate storage into a model where there's less management overhead for them, take away some of that pain, give them more performance out of the storage for less, and make sure that the applications that need the performance get it on demand. They don't have to set up policies. They don't have to understand their data. It's a storage system design.
I would also argue that it's the current processor model where there are 4 or 5 layers of cache just introduces levels of complexity that the performance differences in the storage media don't justify. That let's try and keep it to 2 or 3.
So the latency between in-host caching and SAN caching is significant.
Oh, yes.
And it's one of those concepts where you should be able to build the intelligence into the storage systems to understand at what level you need to cache it if the application requires caching.
If your definition of the storage system extends all the way up into the host. Because if I'm going to put flash in the host and manage that and a layer of cache that's shared, then we'd have to do it up there.
No, I think it's a valid point. I think, and that's the direction in which the storage APIs from the hypervisors should go towards.
Yeah.
Towards more intelligence, sharing with the storage arrays in order that storage arrays and hypervisors can work better together. You're always going to have cache at the processor. You're always going to have RAM on the host. Some of it is going to do caching. Operating system is going to do caching. The hypervisor is going to do caching. You're going to have caching at all these levels. But in a multi-host environment, in a clustered environment, you're also going to have caching at the storage array level.
And we have to start adding.
And that's unavoidable.
And we have to start adding cooperation between those layers so that they're aware of each other.
That's the key.
My point was only that you're talking about it as if it's having to handle this. It's a problem that's already been solved in one layer. You take the same concepts of cache consistency that currently exist and push it out to the storage layer as well.
So it's only a matter of a couple million lines of code. No problem.
The difference is, of course, is that the reason why it always had to be written down to the disk layer was persistence. There was either very, very expensive persistence in the server itself. With Flash, you can now put persistence in persistent storage in the server itself, and therefore you have actually now got inside the server persistent storage, and therefore in the long run, the storage hierarchy will have to be managed from the server and what now is SANs, and in the archive layers down below. So the management system.
We also have the problem that servers are, we've always considered them, even if they're persistent, unreliable. Right. And so if that So
but he's right, is that those problems have been solved.
right,
From
but
an
now we need
architecture
to,
point of view.
now we need
Now-
shared
now they have to be
distributed.
implemented.
No, they have to be implemented, but where we're driving towards is from a storage system that will have to take into account management between storage at the server, storage at the SAN, and storage and archiving. And there's no right or wrong place to put stuff. It's where it's most appropriate.
Right, and it does become, and I tend to agree, an operating system issue there. And, that's where you need to have cooperation APIs, because it's not going to be a bottom-up solution.
It's got to be a top-down.
And Neil, the gentleman behind you actually had a question first. Yes, sir.
I think the argument from a storage standpoint is not the way to see it, because let's put an example, exchange. Different words in exchange behave differently. The latest exchange 2010 was caching internally within the memory with human or index. So relief more IO much less than before exchange. So you don't need the caching because the application software already allocated already.
No, so that's,
But
I think,
if we have periods versus exchange, a different story.
so here's
Right,
the
so-
issue though.
It's an application issue more than anything else. You're caching the bomb. If you put it in a raw application, same OS, then by the additional performance you expect.
Let's say though you have 20,000 users on Exchange.
Yeah.
And you need the capacity to be able to deliver performance, for all those users. And typically you're going to do that using spinning, disk, and you're going to use 15K drives. You don't have to do that anymore. You're actually collapsing your stack now, right? You're collapsing the stack down. So the benefit of the caching is not just in the performance, it's in the how you design a system that drives down a lot of issues. Once you get down to using 12 3-terabyte drives instead of 60 600 gig drives, power and cooling, all those other things come down as well.
I agree. I'm just saying that actually the application dictate what storage structure you want.
Well,
In
by the way,
a
that's-
well-run IT department, the application dictates everything. Infrastructure exists just to support applications.
Right. And that's the advantage, in my opinion, of the caching, because if you are caching a tremendous amount at the server level, you aren't going to hit the cache on the storage nearly as often, and that just means you have more available for other purposes, which is all right.
Okay. Anil, did you have a question?
Yeah, in fact, it's an extension to what he said. So, let's take very specific example, and I like to hear, the different people, how would they respond. You are the CIO. I have a company which is 5,000 people, and it's a virtualized data center. I have not entered Flash as yet. So the question boils down to, I have just two workloads.
Okay.
Oracle database, and the other one is sort of search and retrieve from a humongous amount of information that I keep. So as a CFO, you come to me and say, okay, this is the check. So I say, okay, bring me into two phases, or rather two phases, either plan 1 or plan 2. Where would you put the flash? What performance would you get out of it? It's my money, and you're the one whose job is on the line. So there you are. Right there is very important. Those two
Perfect.
workloads, 5,000 people, because they are generating IOPS and all that to go with it. Very used with Oracle. So if you don't mind, so there's no flash whatsoever. All I have is virtualized servers, and there's some memory to go along with those servers everywhere, but there's no flash whatsoever. And the standard disks are sitting there and all that, usual today.
What year did you buy the disk array?
Okay,
How long is there still on the lease?
Exactly. So that was the next question.
What's the
And I'm talking about the 2013, 2014 budget. That's where this needs getting.
No, but is the
So what
the,
I have,
the
Buying
question
new storage.
is this current storage fully amortized? Can I buy new storage?
Yes.
Do I have to buy new storage? Because if I don't have to buy new storage, I might be doing server-side caching because I'm going to spend a lot more money. But if that storage is on a 5-year lease, and at the end of 2013 I'm going to be returning it and buying something new, then I'm going to plan something else.
The lease finishes at the end of this year.
Okay.
Okay.
Easy enough.
So it's a clean slate.
It's a clean slate from 2013
Okay.
and 14.
Beautiful.
So,
Gentlemen,
well, I think
start
there's-
your engines.
Well, I think there's no easy answer, right? Because there's a lot of other elements in play, typically around, the IT politics, how you
layer
distribute,
8.
how you distribute SAN and NAS in
we
an
don't know that
environment.
much
Yeah, we provide both of those.
Okay, but we're down
Are you
to
going to try
7
and
whole
bring those
seconds.
together in the future? But I think ultimately that's the goal of the design. The design is to be able to bring together high performance database capabilities and more disk capacity intensive solutions on a single system, and to manage those effectively. We've developed a core back-end design where we break up the disks into thousands of tiny little disks and spread data all over them. So we've really sort of thought out how we actually see the I/O all the way down to the disk, and how we can actually make sure our caching algorithms are very aware of what the application requires on the system. And that's really the strategy going forward. It's not build better caching, it's build better management of how your application uses the resources on the system.
Can I narrow it down? You have
Well,
one page.
unfortunately, we've run out of time.
Oh, okay.
And so we have to close with what I, as a consultant of 35 years experience, can say is the correct answer to every question like that. It depends. that there are just too many variables to answer that in
But I'm happy to sit
20
down with
seconds.
you afterwards outside.
How can you get the money from the CFO if that's what the answer is going to be?
Well, because I'm going to go in and say that you have to pay me for 2 days to ask questions, because I'm a consultant. Thank you very much. It's been a pleasure.